Okay, we're going to be talking about how to solve problems, specifically how to put those problems into charts to organize the information. So let's look at a couple of problems. Here are two typical problems that we're going to be looking at. So it says read each problem and complete the chart, then give the equation that is used to solve the problem. In number 1, Marley makes $5 an hour working after school and $6 an hour working on Saturdays. Last week she made $64.50, working a total of 12 hours. How many hours did she work on Saturday? So they've already put in this variable S for us on Saturdays. So if we were to make our table, I would start with Saturdays and weekdays as my my rows, and my columns would be hours, wage, and income. So as I said, they've already put in the variable S for us for hours that's worked on Saturdays. If we know she worked a total of 12 hours and she worked S hours on Saturday, then the weekday must be whatever's left over of that 12, or 12 minus S. We know the wages, it says it in the problem. She makes $5 for working weekdays and $6 for working Saturdays. So we just write the expression for the income here. The income on Saturdays is S times 6. The income for the weekdays is 5 times 12 minus S. The question becomes, how do the incomes relate to each other? Well, we know she made a total of $64.50. However much she made on Saturdays and however much she made on weekdays, all together has to equal $64.50. So we can take these two values for income, add them together, and set them equal to $64.50, like such. 6S plus 5 times 12 minus S has to equal $64.50. And there's our equation for solving the problem. If we go through and solve this problem, we can eventually get the answer. But that's not really what it's asking us to do. For right now, we're really just setting up the problem. And that's how we would set it up. Let's try number 2. In problem number 2, we actually have 3 things we're talking about. The 1 set stamp, the 14 set stamps, and the 22 set stamps. So Ernesto purchased 100 postage stamps altogether, worth $9.90. Half of them were 1 set stamps. The rest were 14 cent stamps and 22 cent stamps. How many 22 cent stamps did he buy? Okay, in our equation, we can use 990 cents instead of $9.90, which makes sense because everything's calculated in cents. So 1, 14, 22 is how I would set up the rows of my chart. And then number, price, total cost is how I would set up my columns. Okay. We know, so let's say, for instance, that he bought X 22 set stamps as they've set up in our box. We have to figure out how to fill out the rest of these. Well, we know that they bought 100 postage stamps. Half of them were 1 set stamps. What's half of 100? 50. So we know he bought 50 1 cent stamps, which leaves us with 50 between 14 and 22. And if 22 is X, then 14 must be the rest, or 50 minus X. Price is easy. 1 cent, 14 cents, 22 cents. And cost is actually pretty easy for these two. 50 cents, 1 times 5 is 50. 14 times 50 minus X, and 22X. And now we just have to add all of these together because remember we want this to equal 990 cents. So 50 plus 14 times 50 minus X plus 22X equals 990. Now, I didn't have to use decimals or any of that because remember I was talking only in cents, not in portions of a dollar. So 1 cent becomes 1, 50 cents becomes 50, so on and so forth. And $9.90 becomes 990. Not all equations are going to end up just adding that final column. Sometimes there's going to be different relationships in that final column that you're going to want to be aware of. But for these two problems and for some of the problems we're going to be looking at tomorrow, the goal here is really just how do we organize the information, and once we've organized the information, how do we turn that information into an equation.